Okay. Okay. Whoever has joined, let's talk for a bit. So, who all has tried writing some multi-threaded coding? Like we have given some homework also, trying matrix multiplication, trying merge sort using multi-threading. Who has tried?
I didn't try merge sort, but matrix multiplication I have tried.
Okay.
And yeah,
It
I've
was
posted.
working.
Yeah, it was working. And the additional thing, like I saw your thread pool video,
Hmm.
and there in that execute task function, you were passing the function along with the parameters, right?
Hmm.
So I just created a library which will
Okay.
like just calculate the duration it took or the time taken to execute that function. So I
Okay.
just took inspiration from there and created a library and used it in the main file of matrix
Great.
multiplication. So it looks neat and clean. So I'm happy about that.
Oh, nice, nice, great. So, are you posting on Discord?
Yeah, I just posted.
Okay, just now. Okay. What about
Yeah.
others? Anyone who has tried multi-threading coding? Anything? Did you also get to see the thread pool video? Because I told that I will not be doing thread pool in the class. Hello, everyone. Let's communicate.
Uh, Hi, Avik.
Hi,
Uh,
hi.
yeah, I'm still to watch your thread pool video. I got
Mm,
started with
mm,
creating, actually reading a little bit about what is the design of like the loggers, like what other loggers look like, because I don't know
mm.
anything about loggers. So I was looking
Okay.
at what are the components of a logger and so on. So I'll try to make something minimalistic first. And
Yeah. So if you're trying logger, now the simple thing is you can have a configuration file where people can give configuration where to log. Like, do
yeah,
you want to log on console or do you want to log on file, and then the file path, right? It is configurable. So, so
yeah,
what you can do in your logger is you can read that file and then set your things up, whether I have to log on console or both in file also. And then you can have different levels of logging, right?
different
So
levels of
info,
logging.
error,
Yeah,
and everything. So if somebody does suppose error logging, then error and above that should all should be logged, like error
yeah,
or above that whatever it is. But if somebody is doing debugging logging, then debugging and above everything should be logged, right?
yeah.
So that you can use. Yeah,
I
and
think they
also you.
have suggested like another feature. So one is formatters are like a common component. I found that
Hmm.
they will have some
Yeah,
formatting.
once you have done this, no, you can then again then go for like little advanced, like how to configure the formatting of the log. Like you can give the user if you want to format it like this or this. Also, when you are logging, so suppose when user is logging, he will only log the line. He will only log either it is info or error log, and then the message, right?
Yeah,
But then when it comes to the file, you also have to show which line number, which file name, and the date and time. So
yeah,
that you have to pick yourself up. So that is
yeah,
one thing how you'll do it. One second. Yes. Yeah. So that you have to see how can you do you can pick the line number and file name.
I've created what I did was I created a Git repo. So for this one, I will actually like properly like for each feature I keep adding, I will create feature branches. So and then I'll maybe just
Mhm.
send it.
So
I'll create a pull
yeah,
request and
yeah,
send it to you maybe so you can
yeah. I'll be
yeah,
happy to check
build.
if you are doing it properly. I'll be happy to check. So also creating logger is a very good project if you can like. So after that, what you can do is once you have created the logger, the formatting thing I'm telling that you can give the user to format in particular way possible, and then what you can do is you can take all the logs once you have done the live networking and socket and all. No? What you can again develop on the logger is you can take whatever the log it is, and in a separate thread you are taking all the logs and putting it to the particular server, right? You are taking all the logs and putting it to the particular server, and this is what happens
Okay.
in the real systems. See, so suppose we have a lot of microservices and each service is logging a lot of things in their own system, right? So there will be a service which will be taking all the logs from the system and keeping it all to a central repository so that it can be analyzed and, some info can be taken out of it. So that you can build on top of that. Yeah, similar to ELK stack. So that is a very good project to build if you can do that. Yeah.
Also, Amit, what is this? I have seen in a lot of this underscore underscore line and underscore underscore file.
Mm, mm.
That
Yeah.
is a macro or like a preprocessor compiler directive.
Yeah, it's a compiler thing. Like if you give underscore underscore line underscore underscore, it will automatically take the line number which where the code is written. So if you do a just simple C out of underscore underscore line, no, you will see it will output the line number. And if you do underscore underscore file, it will output the file in which that code is written.
Okay,
So
but it is
you will have to use that in the logger.
specific like Windows compiler only, or it is in all supported in all compilers.
In all compiler, it will support it. I'll show you how it is. If I
Also
have
regarding
some.
the assignment, sorry, a bit embarrassing, but I tried the STL thing. That itself was very difficult for me.
STL thing, which one?
That you had given an assignment, right? The first one was easy, but the second one was quite tough. The room to remove duplicates and
Second one was difficult. I
yeah,
agree.
I got stuck in there and I couldn't go beyond. So I'll try
That's
to do.
okay. Some people have already done it. You can see their GitHub. I think people have shared also on the GitHub. And
Yeah, but I should try, give more try before I give up. So that is where it
mm,
got stuck.
that is okay. Don't have to like means waste a lot of time in that. You can, if you are trying it yourself, it is very good. But then you can quickly check how it is done, and then that is okay. I mean,
I'll,
right now you are here to learn, right?
okay.
If I have that, I can show you. Config console logger. I don't think I have it. Like this. Like, okay, I'll share my screen. Let me know once you see the screen.
Yeah,
Invisible, right? Yeah.
yeah, yeah.
So if you do it like this, one second, I'll move this one. Yeah. This like this. So you can actually, if you do a C out of this underscore file underscore line, no, you will get the print of the where that this particular line is written. You will get it. So this actually is useful in when you are creating that logger what we are talking. So whoever is creating this project, no, you can use this line. So if a user does this log, it will automatically putting this line and file where this particular log is done, right? So you can try this.
Implementation is complex, right? There's underscore underscore file to get the file name.
Sorry,
Is
come
this
again.
implementation difficult to get the line number from on which line it is?
No, no, this is what I'm saying. No, see, I mean, so when you will create a logger, you will have some logger class you will create, and you will have a logger instance, and you will give a API something like this, right? To give the level and the message. But
So I'm
what
asking
you
this.
can do, uh,
No, I'm
yeah,
asking this implementation of underscore underscore line underscore underscore that internally. Like I've heard these kind of questions before in interview, like how to do this and also like
internally,
how yeah.
internally, how could they have implemented? I mean, this is from the compiler when it is going through that. It checks key, okay, this particular line, wherever this particular line it will find, it will just automatically take that info, line number and file name in which it is written. Like, why it should be difficult for the compiler when it is going through the code
But
while
it won't
compiling?
runtime. I mean the function will be called at runtime also.
Function called at runtime.
Means it will do substitution, text substitution at compile time, but the code
Correct.
executed at runtime, right? So uh,
Chalo,
I mean,
even I am not sure they how, but I think it would be simple for a compiler to do this because when they are like going through the code, they will just keep a tab of what is file and what is line whenever
okay.
you are using this. But okay, let's come
Yeah.
back to what we were doing. Okay, so we were here and this multi-threaded demo I had kept. So we had already done some mutexes, log guards and all. So everyone will start. We'll start. We were doing
Yeah, yeah.
multi-threading last week, and we had some concepts to look at, which were left in the last class. So what we will be doing today, and most probably little bit of tomorrow also, is we'll look at. Let's start with the problem only. So we had already looked till recursive mutex. We have looked, and we have also looked, I think, at time mutex also. When to use time mutex? Did we look at time mutex?
No, I don't think so.
No.
Okay. Okay, so I'll quickly rush through it, like what is type, because once you have understood what is mutex and where it is used, is that clear what is mutex and where it is used? Like whoever are first timers in the multi-threaded coding, are you okay with what is mutex and what is like when it can be used? You understand what is critical section, and if there are shared memory and it is getting changed by multiple threads, you have to synchronize it, right? So that no two threads will simultaneously try to change that. So use a log to synchronize the threads, right? So and there are a lot of threads that we saw. So one was recursive mutex, one was simple mutex, and then we were using log guards, which works on the principle of RAII. Now, now other kind of mutex could be a time mutex, which is something like this, time mutex, and if you have to use it, it gives a something like this. I'll show you the code and quickly go through it. So I'll not spend too much time on all this. Like these are not very important. Once you have understood, you can understand it very easily. So see, so one, how do you use time mutex? So you have to give it like this. So earlier, how we were giving mutex, no, you just have to use a time mutex, right? And then one second, I'll format this. Yeah. And then what we can do is instead of doing mutex.log, what we were doing earlier, what we have to do is try log for or try log until. There are two APIs that are given by time mutex, right? So it says ki, hey, try to take the log only for this much time. If I don't get the log for 1 second, I'll move. Right. So that's why I'm put it in if condition. So if I try for 1 second, if I don't get the log, it will return me false, and I'll go to the else part and I'll do whatever I have to do, whatever the logic I have to check, right? If you want to again keep on checking, you can put it inside a while loop also, the whole thing, right? So that it can come again to this if else and it can again check. So similarly, you have try until, so you can give a particular time to, okay, try the lock until this time, right? Is this clear? Like, is this simple enough, or you need to understand something?
Amit, okay, just one question in
Hmm.
this.
Hmm.
By seeing this, I'm getting a one thing like it is something could be one of the solution for
Hmm.
see sometimes what happens, the threads will wait, right? It's kind of
Hmm.
a thread starvation kind of thing also.
Yes,
It
yes,
might
yes. So
it's
what happens if you have a simple lock, no? When you do a mutex.lock, it will keep on waiting and it will sleep there. Like that thread is not doing any work for you, right? Which is a simple lock. But if you are using this, what it will do is it will only check for 1 second, and then you can use that thread to do some other work. Your algorithm could be something like, okay, if I am not able to take the lock, then do some other work. So your thread is not starved. Like your thread is at least doing some work, right? Or you can still create some kind of spin lock. Like you can keep checking, okay, I cannot get a lock. Let me sleep for 1 second and again come back. Let me sleep for again come back. That is something called spin lock. So you are spinning and trying to take a log, right? Is
do
this
we have
clear?
any like means okay std construct actually for a spin lock, or okay we only have to do no spin lock any
There is,
specific?
means you can use this kind of struct to create a spin lock. Like you can just put it inside a while loop and you can keep moving. And if you don't want to like give it for try lock also, that like for the inside this time mutex, what we are doing, we are giving a particular time to try it at least for this many seconds. And if you also don't want to do that, you can have a simple mutex also. And then like suppose you have a mutex, suppose mtx. And what we can also do is you can use this like this, if mtx dot try lock. So this is something like in asynchronous version. If I try a lock, if I get a lock, fine, I'll get a lock and I'll try to do whatever needs to be done. But if I don't get a lock, it will quickly come out and it will try to do another thing, whatever your algorithm is. So you can also try this if you don't want your any thread to like sleep if it doesn't get a lock, right? So these are some techniques that you can use. So when you don't want any particular thread to like sleep or not do any work if it doesn't get any lock. So it is useful in those situations.
So is this concept also related to this lightweight and heavyweight locks? Like in Windows, there is something that it will try in user mode, which is a critical section construct, and there is something called mutex which will go to the kernel mode. So that is a difference called lightweight and heavyweight. So is it similar
Yes,
to
yes.
timed mutex?
No, it is not that similar, but I understand. Like in Windows, you also have a critical section construct, right? Which is
Right.
in the user mode to lock it, and it is very lightweight and it is much quicker. But then what you are saying is then again you also have a mutex which goes to the kernel level, and then it takes time, but it is more suitable when you are like want to be get more synchronized, right? So
Right.
there is no concept in the standard library something like critical section or mutex lock. It
Okay.
is more of these try locks are asynchronous APIs. So if it gets a lock, fine. It doesn't get a lock, it comes out of that API. That's it,
Okay. Yeah. Thank you.
right?
Amit, I had one question for recursive mutex. Say
Mhm.
there are two threads which are accessing a recursive function.
Mhm.
So say thread one got the lock. So will thread two at any time be able to execute some part of the function, or it has to wait until thread one finishes everything?
Uh, it's like what it takes a lock and it goes in the recursion, it takes that same lock again, right?
Mm-hmm.
You are telling this, right? So one thread suppose came, it took a lock and then it goes into the recursion
Yeah,
and then took another
yeah.
lock, the same lock. But while meantime the second thread came and it is trying to take that recursive mutex, because it has taken that lock, it won't be able to take it, the
So
same lock.
first thread one will finish
Mm.
its execution and then thread
Mm.
two.
Yeah, yeah,
So
I think so.
then why do
But
we, yeah,
mm,
why do we need a thread
mm,
in that case? Like anyway, it's not going to be parallel. It's kind of sequential, right?
no, you are correct question. So one because one thread has already taken that lock, it won't let the other thread take the lock until it has come out of that loop, right? From the recursion.
Yeah, yeah.
Good question. Let me try this once and let me tell you what is happening. Can you guys also try recursive mutex wala thing? Did you understand the question, everyone? What is he asking?
Yeah.
Can you guys try what happens in that case? Is it allowing the take the lock? Huh?
What is the
Has
question?
anyone tried? No. Okay. At the end of the class, let me try this recursive mutex today only. Fine. Remind me, I'll try this. Okay. So moving on. Who asked this question? Sorry, I forgot.
Pooja.
Pooja. Pooja, I will try this after the class.
Yeah, sure.
Okay. Okay. Shared mutex. Okay. So recursive mutex is done. Recursive is done. Time is done. Try lock, everything you have understood. Can we move ahead? Time mutex and all. It is done. You understand when to use it. Can we move ahead? Yeah. Okay. So after time mutex, what we have is other thing. What we have to look is something called unique lock. When should we use unique lock? Anyone knows about unique lock? What is unique lock?
So unique lock can be used in case of lazy locking. So we just have the lock, but we can acquire it whenever we want.
Yeah, correct. Correct. So suppose we are given a situation, suppose like this. We have something called mutex here, and we have a some say suppose some shared variable. Let's start with 0, and then we have a function. Let's say increment, and then what we can do inside increment is we are trying to do this.
Hey, Amit, are you sharing your screen?
Yeah, I'm sharing. It is not there. Yeah,
Not
it's shared.
visible.
No, is it not visible?
Uh,
I can see it is visible.
I can
Oh,
see
okay.
it. We can see it.
Yeah.
My bad. Sorry.
Yeah, so we have a shared variable that I am trying to increase the value of it. If I go ahead, delete all this. Yeah. So now if suppose I have two threads here. So thread T1 and it is trying to start with this increment function, right? And then again I have the one more thread T2 trying to do the same. And let's join them. T1 dot join, T2 dot join, right? Okay, so what I'm trying to do here is there is shared variable which is shared among these two threads, and both the threads will try to increase the counter, right? So we already know that this can go wrong, right? If two threads are trying to interact together, it might change the value which we don't want, right? Like so shared variable, one will take the how it will look for the thread is something like this. So shared variable equal to shared variable plus one. Sorry, shared variable plus one. Something like this, it will look toward the threads, like so it will read the value and then it will try to increment it, right? This particular line, it will happen in two pass. It what compiler does is it will check the value and then increase the value from the past value. So this it will happen like this, right? So there are two things that is happening at a time, and it is being shared by the two threads. So we know there will be a race condition. Agreed? There will be a race condition. Correct. So we need to synchronize this. We need to put a check on this particular shared variable. So how do we do it? We put mtx.log. Simple, right? And then mtx.unlock. If you use logguard, we don't have to unlock. That we all know, right?
But there is
Now,
also something called atomic. Wouldn't that be a better case here at atomic?
that will come later when we'll learn atomic, right? Okay. So we have used simple mutex. We are locking and unlocking. Now what I'm saying is we also have a unique lock. Okay, how it is defined is you can do it here. Instead of doing mtx.lock, you use unique lock of type mutex. You have to give what type, and then let's so call it unique lock, and then you have to give this particular mutex inside in the constructor. So think of it as same as log guard. How you are using how you are using log guard. You are also doing something like this, right? Log guard of mutex and something like this, and you are passing mtx inside, right? So it is similar to a log guard, and it also works on the principle of RAI. It means when I have given this, it has taken a log. So it goes inside the constructor, and inside the constructor, they must have been doing mtx.log. And when it goes out of this scope, it will do a unlock. So we don't need this now, right? So you can also use this unique lock, right? And mostly when we will be writing codes where we are using multi-threading, mostly we'll be using this unique lock. And how is it different from a simple lock? So what in mutex, if it is some simple mutex we are using, what we had to do? We had to do mutex.log and mutex.unlock. Then comes the lock guard, which was solving the problem that we don't have to unlock ourselves. It will just go out of the scope and unlock it. But it gives best of both the worlds. This unique lock. One thing is it will only allow one particular thread to go inside, means it is locking exclusive access, right? And then you also have the ability to unlock at any particular point of time. Like say I can also do like this. So suppose there are other codes that needs to be written after this, other codes, right? There are a lot of other code that needs to be written after this. But I don't want to lock the whole thing, because if you don't unlock, when will it unlock it? When it goes out of the scope, right? But I want to, once my critical section is over, I want to unlock. So you also have the ability to give ul dot unlock when you are using unique lock. This is one thing. Also, one more thing is, once you have given this, what I'm saying is, once you have created this unique lock, it has taken a lock. But what we can do is we can also defer it. I'm telling you this unique lock, hey, don't uh, lock it right now. I think it is like this, defer lock, right? So when I'm creating it like this, what I'm saying is create that unique lock, but don't take the lock right now. So whenever we want the lock, what we can do is, now if I want the lock, I can just do it like this. Same as the mutex.lock we are doing. So that's what I'm saying. It is just doing best of both the worlds, this unique lock. So whenever I'll be writing the code from now on for the lock, simple lock I need, I'll just take the unique lock, because it gives me all those possibilities, right? I can do unlock whenever I want. I can do lock whenever I want. And if I just give it something like this, it will lock for me. And when it goes out of the scope, if I have forgotten, it will just unlock for me. If I have forgotten to give this unlock. Is it clear?
Amit,
Yeah.
is my I was like what I understand is I guess that unique lock is probably like
Hmm.
some kind of wrapper class which is internally taking one mutex, and then in
Yeah,
the
yeah.
destructor it
Same as
will
lock
do
guard.
a unlock, right?
Yes,
Before
yes,
in
yes.
the
Correct,
destructor.
correct. That's what I'm saying. It works on the principle of RAIA, right? We have discussed in the last class also, no?
Okay. Yep. Yep.
So same as log guard, but in the log guard, what the problem was, I don't have the comfort to like do lock and unlock whenever we want. It just does unlocking when it goes out of the scope. But here I have this possibility that I can lock and unlock whenever I want. Correct?
Got it, Amit. Thank you. I have one small doubt here, Amit.
Yeah.
The unique lock can also be achieved with the lock guard with the curly braces, right? On that day class, you
Correct,
mentioned
correct,
that
correct.
you
Yes,
can.
yes. If yes, yes, correct. But right now with this, I don't even have to do this. If I
Yes, yes,
suppose
yes.
at any particular point of time I have to unlock, I will just put dot unlock. I don't have to take care of curly braces now. But you can do the curly braces thing with the unique lock also.
Got it, Amit. I have another small doubt, Amit. When we are
Hmm.
sharing the critical section, right? When we
Hmm.
are talking about here, if you take a shared variable, right?
Hmm.
We are using the plus plus, right? Post increment. You
Hmm.
are saying that whenever a copy
Hmm.
is created by adding one, at that time
Hmm.
some other thread context which can happen because of that the
Yes.
value might impact it, right?
Yes.
If it is a
Correct.
pre-increment also it will cause because pre-increment use a reference, right?
Hmm. Pre-increment, will it happen? Anyone? If we do pre-increment?
As far I remember, pre-increment take the reference and
Hmm.
update it. It won't create a copy. So that context which
But
might not happen.
won't it be the same shared variable?
Yeah, it will be the shared variable that
Hmm.
is still true. I
Hmm.
was not aware of that during the reference also it will happen or not. I will check and
Hmm.
also put it in
Hmm.
Discord, Amit. Thank you.
Yeah, yeah, sure, sure. Okay.
Pre-increment
So
with plus plus shared variable, is it?
yeah, yeah, plus shared variable.
I think compiler might optimize such
This one.
things, I believe, most of the time.
Come means optimize means what optimization?
No, no, what I heard something like this plus plus is more efficient, like something it was there.
That
Where
efficient
to,
is there, that I understood.
yeah,
But will it affect the in the multi-threading scenario? Let's check, right?
okay, okay.
But it is good thing that whenever it is something said, it good thing to just put it inside a log, like synchronize it. so that we don't run into the issues of multi-threading, right? So unique lock is clear, right? When can we use unique lock? And from now point, from now on, whenever we have to use a lock, I'll just simply use unique lock because it just good, it gives a good APIs and all for me,
Yeah, I mean,
right?
so one more thing is, I think that unique lock is like a copy constructible and move constructible, but not a lock guard, because you can have a defer and you can just pass it to the some std move or something to the other
Yes,
function, but I think
yes.
lock guard may not work like that.
Okay, okay.
So
Yeah,
here the ownership
yeah,
of
tell.
that lock, is there anything to discuss on that? Means
And so
one, can we share a lock to other process like this?
other process or other thread or something.
Even other process or thread, both.
You can pass it to other thread by move constructing, but other process, I don't think to other process we can pass it.
Okay.
Yeah, I
Other
think
thread,
yes,
other
that
thread,
is may
yes.
not be possible. Yeah, because only from the OS perspective, something it may be possible, Amit. Like they have like a global mutex something in that means Windows and all they used to write it, but not sure about these whether
I
we
think
can
it
do.
is a name new text, which allows you to use it across process.
Which one?
Named mutex.
Name mutex.
Correct, named mutex, correct.
But that is OS specific, right?
I have only worked with the OS, Windows OS related. These are new for me, so yeah. So I'm just trying to draw the parallels between them.
Oh
Okay.
yeah,
Also, your voice is echoing, Amitul.
No, it is OS specific only. I don't think C++ compiler
correct.
can do anything about it.
Yes. Okay. So moving ahead. So we have done
Amit,
unique lock. Yeah.
just one question, quick one. So here, for example, you are starting two threads, right, with the initializer function increment. And then there is like a unique lock mutex created there. Now, now I think that this Gajanan and Mithun, they were talking about this ownership. Who owns this unique lock object?
Who owns it?
Yeah.
Meaning,
I mean, when you talk about ownership of an object, so what do you mean by owning the lock here? Or...
like, yeah, main thread is there, but it's something like suppose when we'll be doing a class, no, like when suppose we'll be putting it inside a class, we'll create a class, and inside that we'll be using a lock, like unique lock as a member variable or something. Mutex will use. But for that case, unique log will be part of that class. Will be means whatever that particular object which is shared among particular object who will be sharing all the threads will be sharing that particular object. In that case, that is shared among all the threads who is using that particular object. In this case, when you say ki who is owning it, see, unique log is owning this mutex, but when you are asking who is owning this unique log,
yeah,
it's
just
only it's just
I
a
didn't get
object that is created, and then its only lifetime is between these braces, right?
these the scope. You can just say the
Correct.
scope, right? That's
Yeah.
Okay.
Right. I mean, let's not confuse. Let's not go into. I mean, what is the confusion like when you are talking about ownership, right? There
Yeah, I was
is
just
nothing.
thinking that why would you need to, for example,
Hmm.
so I get that it's copy constructible or move constructible. Why would you need to change the ownership? Like, why would you need to stud move a unique lock? What's the purpose of that?
Okay. We'll discuss. Okay.
Yeah, all right. Okay.
Let me also check and we'll discuss. Is there any possibility that we'll need to move this to some other particular variable or some other particular thread and use this lock, right? See, I understand when you are moving this particular mutex, when you are using it, I understand that you can take this mutex and give it to some other person, and then you use this particular mutex. You can do the ownership thing can work, but I'm not sure how this object particular unique lock is helping us when you are changing the ownership, because its lifetime is it's on the stack, right? Unique lock.
Even with mutex, so you were saying about mutex. So why would why can you copy a mutex and can you move a mutex? So those are like questions which like I was thinking about. And why would you need to do that?
We can we can move a mutex.
You
If I
can
go
move
inside
a
this
mutex.
also, no?
Okay.
See, this is a mutex, and see it is deleted. So copy is deleted.
Yeah.
You can see. Can you see the copies are deleted? We cannot copy it. I
Yeah.
think it will be in mutex base, but I cannot see any move is deleted, right?
Yeah, exactly.
So
So
I
there is a
think
move,
it by
default move.
default
That's
move should be possible, right? And also recursive mutex, if you see, it is all deleted. So copy is always deleted as I can see. Can you see this? This is the implementation of all these mutexes.
Amit, one use case is when you return a unique lock from a function, then you will need a move.
Correct. But we need to find a scenario when we are doing that, when we are returning a mutex. Right? Then we'll be able to explain properly why we are trying to return a mutex or maybe a lock or something. We need to find a scenario to understand this.
Because for unique PTR, I have used it to move because sometimes from function you return a unique PTR and then you need to do STD.
That unique PTR is understandable. It's a pointer only, right? Unique PTR when you
Right.
say or say at PTR, that is pointer. That is understandable when you want to like pass it or return it. That I understand. But why will you at some point of time try to return a mutex?
Maybe their function is the only job of function is to create a mutex and give it to somebody. Whatever, yeah.
Okay. Okay. I think let's go ahead. I think this we are going into a lot of details which we don't need right now to write our code, right? Can we move ahead?
Yeah.
Yeah. Okay. Fine. So unique lock, it is okay. We are done with the unique lock. Okay. So now what we'll do is suppose this is the increment I am doing, and after that unique lock, suppose there is another thread void, and suppose if I have to say suppose print shared variable, suppose something like this. And what I'm trying to do in this case is I'm doing a cout of shared variable value, right? And then shared variable, this one, and endl. Okay, so and then what we can do is we can have another thread. Let's say suppose T3, and let's say it is starting with this print shared variable function, and let's copy this 2 times so that we have 2 threads that are going into this print shared variable. Okay, so now what we have now what case we have is now there are two threads which are trying to increment the counter of the shared variable, and there are 2 threads which are trying to read that variable and trying to print on the console, right? Okay, so what I want is, if suppose there are 4 threads, right? So suppose somebody is trying to increment. In that case, we want there is a exclusive lock. When we are saying exclusive lock means if one thread has come inside and it is trying to increment the counter, no other thread should be able to either print it or even go inside this and try to increment it. Means I want an exclusive lock. But if suppose if I come here and when I'm trying, I also give a unique lock here when I'm trying to read it to keep it synchronized. So suppose I give a unique lock and then the same mutex I'm using. Okay, so now what will happen is if these 2 threads come here and it is trying to take a lock, right? It on the same mutex. So what will happen is when reader takes a lock, in that case, right now in the code, neither the writer will be able to come inside nor any other reader will be able to come inside because these are all logged on the same mutex. Is it clear what will happen with this code right now? So any particular thread, if it takes a lock, all other threads will be blocked. Correct? But my problem statement is, if some thread comes inside this, which is the increment wala thread, if it comes inside, it should have an exclusive lock, means no other thread should be able to come inside here or even inside here. But if suppose some reader lock comes, this particular print shared variable wala lock, if it comes inside, I should allow other reader locks to also come inside. So while reading, I can allow multiple threads to come inside. But when some thread is writing to a shared variable, in that case, I only allow exclusive access. No other threads would be able to either read it or also write it. Did you understand the problem statement first? Is problem statement clear? Tell me that first.
Yeah.
Correct?
Amit, okay, I mean, I know that this is just an example, but in general, like print shared variable, like you are reading the variable. Why do we even need a lock there? That's my question first.
Yeah, so that when I'm trying to read, I will not allow any other, when I'm reading it, I'm not allowing any other thread to, like while I'm reading, I'll not allow any other thread to, like, while I'm reading, other thread don't interrupt me, right? It's like that.
I mean, okay, just a second. If this is a shared lock, can and if it is being locked by a thread, can another thread acquire it? If
Sorry,
it is
come
a
again?
shared lock,
No,
if this
okay,
is not
we'll
a
discuss
unique lock,
everything.
and if it is like some kind of
Understood what you are saying. But before that, I want to understand that is the problem statement clear for everyone what we are talking about?
Yeah, Amit. And quantifiable actually to just to clarify your doubt. See, okay, we need a lock here also. Otherwise, what happens? Somebody else trying to write, and then we don't know about what is the state of the shared variable. It may be indeterminate if you don't lock here in this print shared
that's
variable.
something that I still don't get. Like, why do we even need a lock there in
No,
print
no.
shared
If
variable?
you
No.
don't lock it, right? If you don't lock it, okay, let us say you are you are in this line number 41. There is some chances that some other, thread which is incrementing it, and you get the actually incremented value than the like like a before variable. See, there are multiple threads. If you don't actually lock it, then some threads might get some value and other threads might get some other value. It's not
Yeah,
unique.
but reading is an atomic. See, you have a unique lock in increment, right? So that will make it like a atomic kind of thing. The one thread can enter. It'll increment shared variable. It will be done with that. So no other thread can interrupt that increment. And either you will read the value before the increment, or you will read the value after shared variable has been incremented.
No,
So
no, no, no. No. So suppose you have taken a lock here. What you are saying is you have taken a lock and you are trying to increment it, suppose. But
yeah.
while it is trying to do that, suppose many threads have come here to read also at the same time.
Okay.
Right? So while it is writing, I am also trying to read. So that what you are reading to 2, 3 threads, that could become indeterminate. So while it is writing also other thread, the same variable is getting incremented also. So you have to do what you have to do is while somebody is writing it, my reader thread should wait at that particular point of time. If you do not give a lock here, what will happen is I have come inside, I have taken a lock, but there is no lock here. No, all the threads can come and start reading it. Are you getting the point? If you do not put a lock in the reader also.
Maybe
What I
I'll
want.
see an example later. Yeah, it's still not
Yeah.
getting it.
See, while writing, I want nobody should also able to read it also, is what my point is. While
So
writing.
supposing, let's say that shared variable is some value 5, and now one thread is going inside increment and it is going to increment it to 6. And now some 3 threads 3 or 4
Hmm.
threads have come in print shared variable and they want to read
Hmm.
whatever is shared variable. So what is the problem now?
Like
So
some thread might.
reading and writing can happen simultaneously. So like
Hmm.
say in that increment, you're incrementing a value, say from 9 to 10. And
Yeah.
while it is incrementing, at the same time, there can be multiple threads which are trying to print that shared variable. So actually that value is in transition from 9 to 10. So if any thread tries to read during that time, it is like you're not, it's not
Yeah,
the latest value. You can get the stale value, right? So,
correct.
Yeah,
so
exactly.
yeah. So
Uh,
just to
one
synchronize that thing,
problematic
we-
situation here I can think of is that when we are reading the shared variable, we might do some condition checks on that, and in that case, it might be problematic.
That's what this might look a very simple one line code right now, but suppose there are 2-3 lines of code which are inside a critical section, right? If some condition is this, then you are trying to do this, and then you are trying to read at the same time. So that becomes problematic. Your reading will be indeterminate. What you will be reading while somebody is trying to write it on the same shared variable.
Yeah, correct, Amit. Even here also, it might look like a single line of code for us, but
Yeah.
internally, the process instructions and all, no, that will be like 2-3 lines of code only.
Yes,
They
correct.
will store it and increment it, or
Correct.
or even this see out and all those such things are there, right? They
Yes.
still have a more
Yeah.
overhead only.
Yes. So you understand why do we need a log here now? Correct? Correct. So my problem.
I'll ask later in the group. That's good. Yeah.
Yeah. Fine. That's fine. That's okay. Yeah. So now my problem statement is if any particular thread which is a so this is something called reader thread, if I call it reader thread, and this is something who is trying to write, I can call it writer thread, right? And this problem statement is something called reader writer problem. So what I want is if some particular thread has taken a reader thread has taken a log, I can allow at that time multiple threads to read it. Like if I'm reading it, I can allow multiple threads to read at the same time. Correct? But when somebody is writing it, I want exclusive access. No other reader or writer should be able to try to proceed with either this code or this code, both. So this, which will not happen right now. What will happen right now is if suppose a writer has taken a log, reader and all the writers will not be allowed access. That is okay, which we want. But if suppose reader has taken access, all the reader and writer will also not be allowed access, which we don't want. If reader has taken access, I would want all other readers at least can take the access and try to go inside the critical section. Is that clear? So in that case, what we need to do? How will we make this possible? This reader writer problem, how will we solve it?
One thought is that you can only lock it when you are writing it. The others will only check if it is locked or not locked.
Okay.
The
Although
reader
your
will
voice echoing a lot.
still echoing because I now I don't know. Okay, I'll have to reboot my system then. Fine.
Okay. So what we'll do is, so there comes the concept of shared log. Okay. Shared log. So we'll see what is shared log. And to use the shared log, we'll also have to use the shared mutex. So there are two things. One is shared mutex and one is shared log. Okay. So what we'll do right now is, instead of taking a simple mutex, what we'll do is we'll take a shared mutex like this. Okay. And instead of doing a unique lock of mutex, what we'll do is unique lock of shared mutex. And same. And here what we'll do is, anyone, any idea? Instead of taking a unique lock, we'll take a shared lock of the same mutex, MTX of the shared mutex. And that's it. That solves your reader writer problem. And how it solves? See, we have talked about unique log, right? So when you have given a unique log, and with the shared mutex, remember this shared mutex, it still will have a exclusive access. If you have given a unique lock. So if any particular thread has come inside and if it has taken the lock, it will disallow all other threads. Even if in this function or this function, it will have an exclusive access. But if any particular thread comes here, and if it tries to take a lock, and if it can take a lock with this shared mutex, check this. This is a little difference. Unique lock, this is shared lock of the shared mutex. If it takes the shared lock, it will allow all other threads who is taking and trying to take a shared lock. It will allow other threads to take a shared lock, right? But if somebody is trying to take a unique lock, if it has taken a unique lock, this shared lock will also be banned. Like you will not be allowed to take a lock if unique lock has been taken. So that solves our problem that multiple readers can come inside. But when some writer comes, all other threads are like will not be allowed access until this is unlocked. Right?
Is there any limitation for reading number of threads?
No, not like that. No limitations.
Amit, is it better now?
It is better now. Yes.
Okay. My original solution was maybe very elementary, but what I was saying that we could have done it that writer only can lock the mutex, whereas reader will only check whether the mutex is locked or not. Was that a way of implementing?
Means you are saying try log wala thing.
Right.
So what you are saying is I take a normal mutex only, right?
With normal mutex.
So
by the way, I got
log
this
like this.
And if it's locked,
right.
then
and what we'll do? If
then
it is locked,
then we will wait.
But what will happen if two reader threads trying to come inside? In that case, also it is locked, right?
Right. So they will all wait till will the writer will release the mutex, and then they will start.
But also when the reader will release the mutex.
In this case of shared log, multiple read is possible.
Yes.
That's what. Yeah.
Even if you try log, even readers will be blocked. Even if one reader takes a log, other readers will be also blocked, which we don't want.
Okay.
Right.
Amit,
but when you take a
Yeah, I think we use the shared mutex in order to make the reader thread readable, right? Not, I think whenever it's trying to update an increment, we still want to read it. But when the two threads come to read it, right, one thread should wait, right? Otherwise, synchronization won't happen, right?
No.
Let's suppose there is a thread coming, increment is happening. At the same time, other two threads came and try to read it. When it's trying to read, only T2 can access the read. T3 access after T2 completes the reading, right?
No. Both thread can come. So when two threads are coming, there is no, think of it as no locks. When two reader threads are coming. So that's what the thing is. When we are reading it, we don't want synchronization. When I am reading something, I can allow other threads to also read. I don't have problem with that. Only when somebody is writing, then all others are logged. Yeah, tell me.
Then if we comment the 45, then there is no difference, right? If we comment the line number 45 and keep it, then what is the difference in it?
That's what we were talking earlier also.
No. Then write is not possible now. How can he lock when writing is happening?
Sorry, how can he?
Like, I mean, I'm answering to his question because in this case, while writing, reading is not locked. If you comment it.
That's what I said. We were talking just before that only.
Yeah,
when somebody is writing it, reading is not logged. We want reading to be logged when somebody is writing it.
Yes, got it. But yesterday when we tried one question, right, Amit, where we simply put the C out, and when we try to run it, we observe that unsynchronized output. Shared variable.
So correct. So right now this will have problems when two people are reading it. Why? Because your C out is being shared variable and you are trying to write it. It's actually not the read. When you are doing this is not the optimal thing, but I'm just trying to show the code. What you are saying is right. You will not see the proper read.
Yes,
You are right.
exactly.
So why? Because see out, you are writing to see out. Correct. But just think you are this code is something which is reading. Like suppose this is something file read. I am writing some code to read a file, right? Not see out, because see out actually means a writing to a console. So this is not a very optimal, good example for reading, right? So suppose this is something called file read. If we are doing it, then what do you think? When it is proper, right? I can let
Yes,
4
then
threads
it's
to read,
proper.
right? Then we need a
Yeah.
shared lock in that case.
Yes, you are right. Yeah. Thank you.
You know?
Thank you, Amit.
Okay. Yeah. Yeah.
Amit, yeah, is it
Hmm.
possible you could just once again explain like why this lock is needed again in this print shared variable?
Here.
Yeah.
Yeah. See,
Why do
if
we
you
need a
don't
lock in the first place? Yeah.
give a lock, tell me what can happen. If I take this, so suppose my first thread came here, it took
Yeah.
a lock, right?
Yeah.
While it has taken a lock, suppose, don't just look, suppose just to give the example, I suppose I have 2 3 more codes which is in the critical section, suppose,
Yeah.
right? These are all inside the critical section from here till
Okay.
this code, right? This is my
Okay.
critical section. So now
Yeah.
someone has taken a lock at that particular point of time. Will this code execute or not? This code, if other thread come here and it is trying to
Yeah.
execute, will this
Yeah. It
code
can
execute or
execute.
not? But
Yes, it
that
can
is what we
execute.
don't want. If somebody has taken this lock and trying to write something, at that point we don't want this code to be executed,
I see. Okay. Okay.
right? Then what do we
Okay.
need? We need to have a lock. So
So, for
if it is
example,
executing,
this
yeah,
increment could be like writing some big file, and
could
you
be,
are
yeah.
saying that we should be reading the file only after the file has been completely, like, it's completely written, right?
No, 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 not
Like
completely written. So suppose
okay.
there is one thread that is trying to write something. So suppose I'm taking an input, I'm trying to write to a file, and it is happening continuously. Suppose in the while one loop, suppose,
Okay.
right? And then
Yeah.
there are other 2 threads which is trying to read from that file,
Okay.
right? So there are continuous writing happening and there are continuous reading also happening, suppose by two threads.
Okay.
So what I want is when some thread is trying to write to the file, that particular point of time, my threads will stop. Like my threads should not be reading that file, because I want to read either it is not being written or after it is being written, not in the middle,
I see. Okay.
right?
Yeah.
So suppose I have taken suppose big buffer, suppose I am a good boy, something like this. I want reader to either not read I am a good boy or either read the full I am a good boy, not in between I am. I don't want my reader to do that.
Yeah.
But if you
Yeah.
don't give a
Now
lock,
I
that
think
can
I
happen.
understand. Yeah.
है ना? So,
Yeah.
but
Yeah.
if suppose my reader has come inside and he is trying to read I am a good boy, I am okay with other reader also come in and trying to read I am a good boy.
Yeah.
Right?
Yeah.
Clear, right?
So even in
Yeah.
this case, I think that what
Mm.
you are trying to say is the
Mm.
reader thread, for example, from incrementing it from 9 to 10. So the reader thread could read 9, it could read 10. You can't really tell if there is
Yeah,
no lock.
correct.
Yeah.
Correct. Correct.
Okay.
So either if writer thread is writing 9, either I should be reading before it has written 9 or after it has written 9.
Yeah.
Not somewhere hanging in between.
Yeah. Cool. Thanks.
Okay. Okay. So this is reader writer problem. This gets asked in interviews. So you should be very clear. And I'm giving a very simple way to write it. You understand first the problem. What is reader writer problem? I hope you have understood it. So there are 2 functions. One is trying to read something, another is trying to write to the same memory location. It could be a file or it could be any other memory, right? So multiple threads can be reading at the same time. But when one writer is trying to write, all other writers and all other readers should not have access to that. Is what the reader writer problem is. And how will we solve it? Instead of using a simple mutex, we'll use a shared mutex. Remember this step: shared mutex. And where we are writing, in that you use unique lock with the shared mutex, and where you are reading, use a shared lock with the shared mutex. That's it. Your problem solved. Okay, done with the reader writer. I'm taking it as done, the reader writer problem, and moving ahead. Fine. Fine, right? I can move ahead. Okay. Okay, so let's take the next problem statement. Okay, many of you can guess what will be the problem. So my problem is, suppose I have a simple queue. Sorry, include queue. And these are good for the interviews also. If somebody is taking multi-threading coding round and all, this will be get asked. Reader, writer, deadlock, the next what we are going to do. So we are included queue. So now my problem statement is, suppose I have some buffer. Let's call it buffer size. Let's give it 10. Suppose. Okay. And inside this, what we'll do is, we have some function queue data. So let's say from I equal to 1 to I less than, suppose buffers, not buffer size, let's say 100, I plus plus, and what we are doing is q dot push, and let's say we are pushing I, right? And then there is some consumer who is trying to read the data from the, so read the values whatever is inside the queue, so continuously, right? So suppose what I'll write is, if q dot empty, if q is empty, let's say we have two consumers, right? Two threads are trying to produce, two threads are trying to consume. Okay. So what will happen is, as a what my problem statement is, I have set my buffer size as 10, right? And I want at any given particular point of time, my queue size should not exceed this buffer size. This is my problem statement. So see, here we are creating 100 data, right? From 1 to 100, not 100, I think it is 99. So this is 1 to 100, right? So I'm trying to push inside the queue. And while consumer is trying to do what? It is trying to take out the data from the queue. It is reading it and it is popping. It is means consumer thread is taking out the data and the producer thread is trying to push the data. That's why we are calling producer. That's why we are calling this as consumer. But my problem is, not at any particular point of time, my buffer size should not go beyond 10. While also when we are doing front, if you know the API of this front, if suppose you have an empty queue, right? At that particular point of time, what will happen is, if you are doing a trying to take out the data from the empty, it will throw you an exception. It throws exception if you are trying to take out the top in an empty queue, right? So you also have to save that. So you are consuming when you have some data, and you are also making sure that your buffer should not get beyond this buffer size 10. So how will you solve this? And this problem is called producer consumer problem.
Could you come again on buffer size? Buffer size is the size of the queue, or what is it?
I have, for my problem statement is, I don't want to increase my queue size at any particular point of time beyond this buffer size,
But you
which
are
I have.
already pushing from 100 items in the producer, right?
Exactly. So I want, okay, I'm pushing it, but other consumer is also taking it out, right? So suppose 10 data has gone inside queue. So I want 11 data should not go inside queue until other consumer has taken out and emptied my queue.
Clear.
है ना? So this is called producer consumer problem. So how will you solve it? Any idea?
So Amit, what I feel is that you cannot optimize it like you did it there. You have to use hard locks both places. Is it right?
Yes, because it is not the case of just reading it. The consumer is trying to take out the data and the producer is trying to push the data. So it is not the case of reader-writer problem. Reader one was just reading it. That's it.
So only way is you have to use coarse-grained locks. That is lock both producer consumer strictly.
Yes. So suppose if I take a lock, mutex mtx, and let's say we take a lock here, mtx.lock. And also suppose we take a lock here, mtx.lock. Okay. So, but how it is solving our problem still? What I want is when my buffer reaches the queue size reaches the suppose 10 size, this buffer size, I will not be able to push the data anymore until my buffer size is reduced from 10. While in consumer, I should be only take out the data only when the queue is not empty. Otherwise, I should wait for the data to be pushed. So that this is the case of how one thread is going to signal something to the other thread. Right.
You need to put an if condition, no, in the producer. If I is 10, sorry, queue size is 10, then it should not be allowed to push.
Okay, but how will it come to know?
We can use condition variable here, and we can check the size of the queue. And whenever producer produces something, we can notify the other thread that okay, queue size is changed, and consumer can take some action.
Yes. So we have to use something called condition variable. So we'll use condition variable hash include, which is inside this header file, condition variable. And why we use condition variable? When we have to signal something from one thread to the other thread. Right now, we don't have any means to tell this if some producer thread has come. My producer thread has no means to tell ki, hey consumer, I have reached the buffer size. You can now try to consume it and little bit empty the queue, right? There should be a mechanism so that these two can communicate between each other.
But if with the if condition, it doesn't solve the problem. Like producer will only produce if it is less than 10 or equal to, less than 10. And consumer will be consuming it. So when it goes less than 10, then it will again start pushing into the queue. That won't solve.
But how do we know?
A queue dot size say.
But it won't wait there, right?
Yeah, it won't wait there.
Means?
Like at the 10th step, it won't wait. It will. He wants it to wait there.
Yeah, so that's why I said if condition should be there, that what is the queue dot size before pushing.
So where do you want it? You want here?
Yeah.
Okay, if queue dot
size
is less than buffer size.
Yeah.
If it is less than buffer size, then we'll push.
Right.
है ना?
Yeah. Else we continue or may I minus and same thing like.
Okay, so just think about the multi-threading scenario. So suppose one producer has come, it has checked, it has taken a lock. We are taking a lock, is it?
Right.
We have taken a log and we are checking if it is buffer size is less than first it is q.push. Where should I put this log first? Because it is inside until it goes outside the for loop, it is already logged.
Right. Right. So it has to be there only because q dot size can change if we put it inside.
Correct.
So yeah, it will be coarse grained, but I'm saying this will this. No, I'm just trying to understand the problem about condition variable will solve better. This way be not efficient, but will it solve the problem?
Yes, sir, it will solve the problem. I mean, this whatever you are saying, it will not solve the problem only in the multi-threading scenario.
Why?
Again,
Why,
if it
Amit?
is
Why?
if it has taken the lock, how will we unlock it first? When we are going to unlock it? Can we unlock
Yeah.
it here?
No. We will unlock it
Where?
outside the if condition. No.
Okay. Else part is it?
No, not else. There is no else. Mutex dot unlock.
Okay. Mutex dot unlock.
Maybe a sleep or whatever, just to get means to give some respite to the CPU, so it doesn't get a typed loop.
Okay, but you are again sleeping, right? Which is not good actually in real sense.
Yeah. No,
It
that's
would
what
be
I'm saying.
too heavy, right? Like every time mutex is acquired and then
Yes.
unlocked, and it happens continuously. So
Yeah, either you will be sleeping or you will. There is no way without sleeping to guarantee that this lock will not be again held.
and also the value of I will change. Like say I's value is 11 and its size is already 10.
No,
So it
Yeah.
won't.
for that I told that we can do I minus minus, so that the I value will remain same
Okay.
in the else part.
See, without condition variable also it is perfectly okay because without condition variable you can solve this problem.
Right.
It is solvable. I'm not
Okay.
telling it is not solvable. You can have some kind of shared variable that is both producer and consumer can see. Then you can try to write some particular condition like this. What you are trying, it is
Okay.
solvable, no doubt. But there are other very good method that is given by our OS or our standard library that you can use, which is called condition variable to signal something from one thread to another thread.
Okay.
Right.
Yeah,
So
let's look at it now.
Yeah. So this is good discussion. You should also think like that. What problem does variable is solving that we cannot do properly without using it.
I
Right?
had a question, by the
Correct.
way. If you went with this for, I mean, I think that Mithun was saying we can't put this lock or we shouldn't put this lock inside the if. Why is that?
Inside this if.
Yeah,
Is
because
there a problem?
Yeah, there is a problem because the queue size may change, right? Like I may read the queue size as say 9 or maybe 10, and meanwhile I go inside, and at that time the queue size reduces. So whether it will have an impact, I'm not
I
sure, but
see. I see. So there is some other thread that
which can
went
reduce
and
it.
pushed
Okay.
or reduced it. Yeah. Okay. Yeah. Went
Okay.
and popped it off.
Okay. So moving forward, what we'll do is we'll take a condition variable. Let's call it CV. And what we'll do is, so when we are trying to produce it, so let's remove this code for now. And we had code was q.push, right? So q.push, right? This was our code. We are pushing the data. Okay. So what we'll do with condition variable is check this properly. Okay. So for using condition variable, you need to have a mutex. Okay. And what you can do here is while trying to push, you can do is cv dot. You have to do a log. Check this unique log. So I take a unique log of mutex of type of mutex, and which is unique log, and then I give this mtx. This is the log I have taken. After this code, this particular thread will be logged, right? And then it will try to push, right? But what we have to do is we have to only push when my size is less than buffer size is my only condition, right? I have taken a log, but I will try to push only when my size is less than this buffer size. So what I will do is cv dot wait. Inside this, it needs two things. First parameter it needs is the unique log. So this particular log, what we have taken, it will take that. So unique log. And the second variable, second argument it takes is a function or lambda or whatever, any callable. So what we can do here is we can write a lambda. And what the cv.wait does is it will check the return type of this particular function. It has to be Boolean, right? It has this function should return a Boolean. If it returns true, it will go down. Like it has taken a log, it will check in the cv.wait whether this returns true or not. If it returns true, it will acquire, it has already acquired, it will keep acquiring the log. It will go ahead, it will try to push the data, right? And in what case it should return true is our condition should be. In what case this should return true? If my, tell me what's in what case it should return true?
Q dot size is less than buffer size.
If q dot size is less than buffer size, right? So if it is less, it will return to, it has acquired the log, it will try to push. Fine, right? But after pushing, what it should need to do? It should let other people also have the ability to go ahead and read. Like in the consumer side, it should let another thread to also say, see, consumer, I have pushed something, you can try to consume if you want. So this should be, so there are two things. Either should I unlock first and notify, or notify or unlock first? What should I do? See,
Unlock
until
and
unless
notify.
if I don't unlock, other consumer threads might be logged at that time, right? So should I unlock first and then tell the consumer thread key you can unlock, or what should I do? Any idea? Unlock or notify, notify or unlock?
Unlock and notify.
Unlock and notify only.
Okay, so if I do a unlock and notify, right? So suppose ul dot unlock if I do, and then you are saying cv dot notify. I can also do notify one and notify all. Difference only is all, if I do a notify all, whatever the threads that has been waiting on this particular mutex will all be notified. And notify one will tell whatever all the threads that is waiting on the mutex, only one particular thread will be told, hey, you have been notified. So only one thread will wake up versus all the threads will wake up. But only one thread will get the log, even if all the threads has woken up. So it's up to you. You want to decide. So mostly what, see, when you try to decide when do you want to notify all, when you want all the threads to wake up and try to take a log. But in that case, what will happen is there will be a lot of contention between the threads. All the threads will start coming and trying to take a log. While against that, if you do a notify one, all the threads who will be sleeping on that particular mutex, only one particular thread will be notified and it can try to take a log. That is the difference. So depending on what do you want. If you notify all, thread contention will be there. A lot of threads will suddenly wake up, right? So let's start with notify one first.
How do we decide like which thread we can hit the notify one? Let's say there are n number of threads. Then
So whoever all are waiting for this particular mutex, OS will decide any particular thread it will notify. You cannot tell which thread.
right. Thank you.
Right. Okay. So why it is giving error? Okay, we missed a semicolon. Okay, so we have notified one, we have unlocked. Let's see on the consumer side what we can do. So while one, let's write this properly again. So what we were trying to do here was we were taking int data is equal to q dot front, right? And then q dot pop. These are the two things what we have to do on the consumer side, right? So first thing is we have to take a log, right? So unique log of mutex, and then let's call it unique log and then give a mutex, right? So we have taken a log, but one sec, format. Yeah, we have taken a log. Now what we'll do in the condition variable, I should be able to take the data out only when it is not empty, right? Yeah, correct. Getting my point? So what we'll do is cv dot wait And the first parameter is UL, unique lock, and the second parameter is some function returning bool, right? And now when should it take the lock? When should it go ahead and do this? What should be the condition?
Queue size is greater than
Q
buffer
dot
size.
size greater than 0.
Or we can do that, or we can also do this. If not of Q dot empty. Fine, right? Is this correct?
Yes.
But
So what will happen?
the problem statement was at any time the buffer size should be 10, right? Or is it not like that?
No, not any time should be 10. It should not go beyond 10 is the problem.
Okay. And also I have one question. So generally in Lambda, to access any outside variable, we capture it, right? So how does it work without capturing here? Like we are
Because
able to access and
this one,
buffers.
QU,
Yeah.
because it is shared variable. No, it is
Like,
on
do we have
global.
to
That's
capture
why.
it?
Because it is on the global, that's why we are not capturing it. But if something would have been here inside, which is declared inside, we will have to capture it. Otherwise, why we were able to use without capturing anything? Because it's a global variable we are using.
Yeah.
It will be able to see it. You are correct. If you have to access, suppose if you have to access ice or some matter, right? So you will have to capture that ice. Then only you will be able to use it inside the function. Correct?
Yeah. Okay.
Yeah.
Sorry, one more doubt. First time I'm seeing the lambda. The lambda which you are entering into the braces, right? Whether it will be on the same stack or it will be like running.
It's a different function altogether. Think of it as a different one function.
Okay. So it will be a stack created.
Yeah, different function. Yeah, correct.
Okay.
So don't get confused that we are able to use QU without any capture. Why we are able to use? Because it is a global variable right now. Correct? So what will happen on the yeah.
Sorry, Amit. Sorry for disturbing. The thing is that even the capture list, by default, it will take reference or equal to the global variables.
By default, it won't take anything until unless you provide.
Yeah, then I think Q is how even the global variable that lambda doesn't know, right?
Why?
Because it's a function, lambda function is a function pointer of thing, doesn't have any storage, right? We simply calling there means we are creating the function definition here itself. It should know the data which is to be there inside of it, right? Scope is limited to there, right? We should mention something in the capture list.
Is it? So can we
By
run and check?
default, it will take with equal to, as far I remember. I'm doubt on that. I need to check it.
No, actually, what Amit told, that is correct. Actually, for the global variable, you don't need a capture. The capture comes only in that function, which are above the lambda. Some variables are there for that only.
So suppose I have some int counter or something here. Something. And I want to use this inside this function. So suppose I want to check if counter is something or not. So I will not be able to use it. If you'll see, it will start giving me compilation error. See, an enclosing function looker cannot be referenced. But the moment I give a equal, suppose I give a counter, it will be able to take it. So if I give it like this, it is taking as copy. If I give it as ampersand, it will take it as, sorry, if I give it right. We give it before or afterwards? Before only, no?
Before only.
So it is taking now as reference. Whatever you change inside will be reflected outside also. And if you want to capture everything, you can take equal to or ampersand, either by copy or reference. Right? By default, it will not take anything. Why it is taking right now? Because it is a global variable.
Got it. Thank you, Amit.
Yeah. So quickly, I'll wrap this up. So on the consumer side, can we wrap this up quickly? Consumer one. Yeah. So what is happening on the consumer side is, if suppose one consumer thread comes here, and if it takes a lock, if it is able to, and it is not getting locked by anyone else, suppose no other thread has logged it. So suppose consumer thread comes and it has logged it. This code is not there. It will go inside this condition variable dot wait, and it will see it has taken a log, and it will see the return type of this particular function. So what will happen? Suppose this is a very first time and our queue is empty. So what this will return? It will return false, right? or true. It will q dot empty will return true, but not of that is false. Yes, yes or no?
Won't it return only if queue is not empty? And it will sleep on that for till queue is not empty, or it will come out?
No, that's what I'm saying. First, the very first time when our queue is empty, what this will return, this statement.
This will return
Returns false.
true. False.
This will return false, right?
Yeah, false.
Empty will return true, not of empty will return false.
Okay.
Right? So once it sees false, what it will do is, remember this. If it sees false, that this function is returning false, what it will do is, because it has taken a lock, it will first unlock it. It will first unlock it and then keep on waiting until somebody has notified. Are you getting the point? If it returns false, because it has this, remember we have taken a lock first and then we were calling this function. So if it returns false, first it will unlock so that other thread gets a chance to take a lock. So suppose in the meantime, producer thread comes here. Because it is unlocked, it is able to take a lock. It goes inside and it sees, okay, my queue size is less than buffer size right now. So it is true. It will come inside. It will try to push. So suppose one is pushed and it unlocks this particular mutex and it notifies one thread, whoever is waiting on this particular mutex. It was waiting on this mutex, remember? It has unlocked and it was waiting on this mutex. So this thread will get a chance to wake up again. If it wakes up again, it will again encounter this line and it will see ki, is queue my empty again now? So now it is not empty. Remember, we have pushed one already. So if it is not empty, it will return true. And if it returns true, it will come here. It will take out the data and it will pop. And after this, what we need to do? Once we have popped out, remember what we have to do? We have to unlock. Yes, we have to unlock so that other thread gets a chance to take a lock. And then if anyone is sleeping on this particular condition variable, which is like cv.wait or someone, we can say cv.notify. So this is completed. Your producer consumer, we have solved it. So this thread, suppose, is notify all other threads which is waiting on this particular condition variable, this same condition variable.
Could you come again on line number 84?
84, this one.
Yeah.
So once it has unlocked, so did you understand till here?
Yes.
So, Amit, I have a small problem, doubt. See, when we do cv.wait, not q.empty, then okay, q is, let's say, empty. So that will return true and the lambda function will return false. But cv.wait is not returning, no? That will unlock the mutex, but it is not, it is still waiting for the queue to be non-empty. Is that correct?
No, not correct. How it works is, and how condition variable works is, once it says wait, it will check and it will check the return type of this. If it is false, whatever the lock it has taken, this CV is also attached with mutex. If you see,
right,
this right. So whatever the lock it has taken, it will first unlock and then it will keep waiting here. Just like the simple lock and unlock happens, no? It will keep waiting here until someone has notified.
Okay.
When will it notify it? From the other thread? I am notifying here ki, hey, someone is sleeping on this particular condition variable. Now you have a chance to wake up and do. So once this statement gets finished, this particular thread will wake up and come back here again.
Yeah, but that wake up, that wait will happen inside the wait only, no? Wait function only, no?
This here.
That wait, whatever you're saying for the mutex will happen inside the wait function only, right? How can it go back on line number 77 as far as control flow is concerned?
Control flow, you are right, but take these two statements together.
Okay,
once
got it.
You take these two statements together, locking and waiting. Once it doesn't see a lock, it keeps on waiting again.
Got it.
And it removes the lock. Remember this, it also removes the lock. If it doesn't remove the lock, then other thread won't be able to get inside.
Okay, got it.
Right.
Thank you.
Take these two things together. Right. So if you see this statement only, think of this statement as two things. Only this statement. It checks. If it returns false, unlock and keeps on waiting. And if
Right.
somebody notifies, it again checks this whole thing again.
Okay.
And if it returns true, then lock is held. Whatever the lock was there, it acquires the lock and then goes down.
Okay.
Right? So yeah.
Initially, this unlock, it is a feature that unique lock does, or it's a CV wait when you pass a UL.
Inside the CV condition variable is also having this lock also, right?
Okay.
So it knows if it is not able to return this inside, what it would have been doing is cv.ul.unlock inside,
Mm-hmm.
right?
Okay.
So that others get a chance to go inside in the producer.
Okay.
So understood, right? How are we solving this producer consumer problem? So with this code, at no point of time my buffer size will go beyond 10. Is that understood with these two codes together? At no point of time, however many threads I put it, at no point of time my queue size will go beyond this buffer size. And at no point of time, I'll be able to take out the data from the empty. If it is empty, my code will never come here and on line number 81. And similarly, my code will never come here if my buffer size becomes if my size is become greater than buffer size. So timeout of?
Yeah, I think Amit, I have a query there, timeout related thing. I agree in this particular scenario, we are waiting unlimited of time until someone notifies to us, right? Is there any way that we can make the conditional variable for only waiting for some time?
We can. I think there is a way to, if you see its function, no, what all it takes. And also remember one thing. When you are doing this cv.wait, no, by theory, what we know is that it will keep on waiting until some other thread tell me to wake up, right? But these threads also does some spurious locks in the meantime. Like it will just wake up and check, oh, is it not okay? I'll go back to sleep again. So spurious logs also remember this. Even if it is waiting and I'm telling until it notifies, it won't wake up. There are some spurious log which you cannot define when it can wake up. That is done by OS and it is related to hardware and all. It does a spurious logs also in between. So that also you should keep in mind. And any thread for that matter. It does a spurious log. For the timeout, what you are telling, it has two overloads that we can check if it can take a time also. For that much time, we can sleep, something like that, right? What you are asking.
Yeah, I think wait until is also there. I'm just checking in the VS Code. Wait until option
Correct.
is also there.
I'll also check. Wait. See, it is there. Wait until and wait for.
Yes.
Can you check this? So what we can do is if I use a wait for, I have to also give a time. If I see properly, you can also give a time, wait for how much time, and then again you will have to, I think, do this. If while a condition you'll have to give. You wait for this much time. If you don't get the log, do something and then come back again. Something like that.
Yes,
The
yes. It
same
is taking also
concept.
the object of CV status, condition variable status, whether it is true or false, the condition.
So that is clear only, right? If you understand this,
Yes.
then that is clear.
So this will be a polling method or a signaling method, like
Signaling. This is signaling method.
okay.
One thread is signaling the other thread, and this particular condition variable concept you will use when you have to notify from one thread function to other thread function. See, something is happening to coordinating between the threads. Whenever you think about coordinating between threads, you can think of condition variables at that time. So right now, if you see, we are coordinating between two threads, producer threads and consumer threads. Okay, hey, I'm done this, you can do this. Hey, I'm done this, you can do this. At that point of time, think about condition variables. Correct?
Amit, can you give an example where notify all is useful?
People generally use it like if some people tend to use notify one or some people tend to use notify all. Only problem with notify all is suppose there are 10 producer threads. And if I do a notify all from consumer, all the 10 producer threads and even if all the consumer threads who all are there, all will be woken up once at all time. Like it will be woken up at once and all will try to take the log. So that can take a lot of CPU cycles for some think of for each thread. While notify one is more like out of all the threads, you are just notifying one particular thread, and that is taken care by OS. So what I believe is notify one is more better. What do you think? Like if anyone has any experience with notify. Right?
Does the notify one, Amit, is it telling to the producer thread or consumer thread only? Suppose
Any
there
thread
are
which is
two.
any thread which is logged on this particular condition variable. It could be any thread.
Okay, okay. That
It
might
could
be
be
the
a
reason
producer
the
also, it
wait
could be consumer
will
also.
unlock, right?
Sorry?
The wait doesn't unlock it, otherwise producer won't produce it, right? It will be a deadlock
Yes, yes,
condition.
yes. They are not deadlock. Deadlock, so both threads cannot move. Here, so one thread will keep moving, no? Right?
Yes, I'm saying that if the CV wait doesn't unlock it, suppose if the CV wait doesn't unlock the thread after seeing it is empty, right? So producer cannot enter into create that queue, right? Here it is
Produce.
unlocking. That is the reason producer is able to push it, right?
Yes, yes, yes. Correct. You have to unlock it. Otherwise, if you don't unlock it, if I don't unlock at both the places, once one person has taken lock, it will never unlock for the other person to take the control. So you have to make sure you unlock it before you notify. Right? But there are also theories and lot of debate happens on whether you should unlock first or notify first. So some people say if I unlock first at this particular point of time, what will happen is because of spurious lock I was talking, other thread might just wake up and then they will go to wait this particular. They will check okay it is not empty. It will go inside it, and it can create a problem for you at some code. It can create a problem that even before you notified, the other thread start going inside only. While some people say if I give a notify one first and then unlock, what can happen is if I notify, other thread will just wake up okay I have been notified, but it will again check. What it will try to do is it will try to take a lock, but because we have still not unlocked, it will again go to sleep. That can also happen. So, and a lot of, if you see on Stack Overflow and everywhere, no, you will see a lot of debate happening between whether we should unlock first or notify, or whether we should notify and unlock first. Right? If you have time, you can also check which one is better. I've also put it in notes also, whether you should unlock and notify or unlock. But no one, you will see not a clear answer between both of them. Some people prefer unlocking and notifying, some people prefer notifying and unlocking, and both have their own pros and cons. Okay.
Hi Amit.
Yeah.
Hey, one it will sound silly, but anyway, if I had, I mean, I'm just asking for some understanding. If this unique
Yeah.
lock in the consumer function,
Mhm.
if the unique lock is replaced by a shared lock,
Unique lock is replaced by a shared lock. Okay.
that itself is also a problem, right? Because here we
Yes.
don't want multiple reader or multiple consumers to
See, what will
actually
happen if I put a
pop
shared
off
lock
the
here?
queue at the same time.
Yeah. What will happen if I put a shared lock here? So it means somebody who has taken a shared lock. Suppose there
So
are
I
four
think that,
consumers.
yeah,
Suppose there are four consumers. I took a
yeah,
shared lock. It means
yeah,
if other thread comes on the consumer and take a shared lock, I will be able to allow it inside. Right? And it could happen is
yeah,
this
yeah.
code here or not? This cv.wait.
It is there. It is there.
But if it is there, and then what we'll try to do is again lock, but again
So
all the
the
consumers can
problem
come
that I
inside.
thought,
Hmm. Hmm.
yeah, the problem that I thought is like that. Let's say that there is only one element. So
Hmm.
and there are two consumer threads. Now,
Hmm.
first consumer thread came inside. It was able to acquire the shared lock. It checked queue is not empty.
Hmm.
It is at this line 83, suppose. Int
Hmm.
data equal to queue dot front. It
Yes.
read data, but at that point now it got preempted by that other consumer thread.
Huh.
It goes ahead and it pops the queue off.
Correct. And it will
And
see a empty and it will throw an exception.
yeah, Yes.
It can create a problem. So not
Yes.
good
Yeah.
idea to create
Yeah.
a shared lock here.
Yeah.
Yeah, correct. ठीक है. So that thing, remember, shared lock only when you are okay with 2 or 3 threads only trying to read something, not trying to pop out or trying to write at the same shared variable and all, right? Otherwise, for everything else, you think of unique log, right? And when you are using shared log, you have to use shared mutex. Correct? Moving ahead. So we have done a lot of things, like we have done shared mutex, shared log, condition variable, producer consumer problem, reader writer. We had in the last weekend, we had already done the deadlock wala part thing, what is deadlock and how to remove deadlock. So those are most common things in this multi-threading part is done. So what we can go ahead is condition. Any question with this producer consumer reader writer and all? Semaphore, I will just show you a code. Means this is not so much difficult to understand. Once you have understood all these things, semaphore is not difficult.
Also
We can also
futures and option. This one futures.
you are going to trading.
No, sorry.
Futures and options.
No, futures.
Okay. Futures and promises. है ना? Okay, so semaphore, I will just introduce it. I will not go much into detail. Also, if you know, if semaphore can also be used to solve the reader-writer problem. So, any particular problem anyone has with this three things: deadlock, producer, consumer, and the reader-writer. And also race condition, everyone understand how to, what is critical section, everyone. If you understand these many things, okay, let's count. You understand what multi-threading is, how to create a thread, how to like give a starter function as lambda or any particular function that you have understood. That is one point. Second thing is how do you pass as a reference or how do you pass as a reference variable or copy to a particular function inside the thread. That is second thing. Third thing, you understand what is race condition, what is critical section, what will happen if we are trying to read and write at the same time on a shared variable. Basically critical section, what can happen, race condition, and how to avoid the race condition using mutexes. Then we have different kinds of mutexes like normal mutex, then shared mutex, then you have recursive mutex and time mutex. Inside mutex also you have different APIs like normal lock and then try lock. Then you have some different locks like lock guard you can use, which are based on RAI concept. Then unique lock also, and when to use unique lock and when to use lock guard, that also if you understood. Then there are different problems like deadlock, reader writer, and producer consumer. Each what problem it is, how will we solve the problem using what we have solved, like producer consumer getting solved using condition variables, reader writer we are solving using shared mutexes, right? And deadlock we are solving using lock, like locking all the mutexes together or locking it in particular order, right? If you have understood this much, whatever we'll do now will be easier only. So whatever we'll do, like whatever promises, futures, async, these are just made to make the coders life easy only. These are like the wrappers above all this, whatever we have studied, right? So you should be very good with all these concepts we have done till now. If you are good, then it is easier from now on.
Can you just touch upon this atomic? I think it is just to increment variable and used for these kind of things, right?
I'll touch upon atomic. Most probably tomorrow we'll start with that, and that I'll want to take it separately as a log-free programming.
What is
right?
it?
Log-free programming. So
okay,
right. So without using log, how we are going to do the multi-threading programming? And that actually speeds up more, like gives you a more throughput. So if you are using multi-threading and then to synchronize, you are using logs right now, right? That is the basic template of a multi-threading.
Yeah.
But even without using logs, what you can do because when you use log, there is one thread is sleeping, and then you create a mutex. Those all things takes time in the OS layer, right? But we can still speed up by not using logs, by using something called atomics and all, and compare and swap mechanisms. And
is
that I
it the
want to take it
same?
separate.
Is it the same what we discussed, like user mode and kernel mode, when you can avoid going it to the kernel mode and when you can manage
No,
just
not
not?
the same. Not the same.
Okay.
That kernel mode, user mode, I will talk during when we are talking about networking, right? I have thought about it. Like we'll see ki
Okay.
while using networking socket, what is happening in kernel mode, what is happening in user mode. That we'll talk. But
Okay.
till this point of time, everything is clear or not? Because after this, everything is just the wrapper above all this.
Yes. Yes, it's quite good, quite clear now.
Okay. So after this, what we'll do is tomorrow we'll be starting with the lock-free programming. That I think will take around half an hour or something. So that is also a very good concept to know. If you have understood this much, you should also level up, right? Okay. So after this, we'll try to see quickly promises and futures, what it is. And I'll show you some code and tell me if it is easier or not, whether you have not understood. I'll try to rush through it. But if you see any problem, you'll just stop me because I think these are now easier only to understand. Okay. So let me do one thing because I've written a lot of code here. I'll make a new file. Let's call it
Is there material
main2.cpp.
you want to suggest us to go for a read? Any material books that?
For this multi-threading thing?
Yes, multi-threading and different kinds of locks. And this lock mechanism, it's a CPP specific. What about that? There will be system specific like P threads which are getting used, right? How much it's it is a
Not
wrapper on
required.
that. It is a wrapper kind of thing which CPP does, or it's like it's a two
No.
different concepts.
So whatever we are using, like thread create, whatever we are using thread class and all no, to create threads or mutexes and all, these are actually the wrappers above those p threads or create threads on Windows. Whatever we are using is the wrapper.
Mm-hmm.
Those are the system level calls. Like on Linux, it is pthread. On
Okay.
Windows, it is create. I think we have discussed this also in before also,
Okay.
right?
Okay.
Right? Okay.
No,
So
the thing is that I was more interested in what is a thread safe. There are concept of thread safe all around, right? Multi-thread safe.
multi-thread safe.
What is the meaning of multi-thread safe?
So whatever the code we are writing, suppose this particular producer consumer, suppose
Hmm.
without writing all this unique lock or cb.wait, whatever we have done, if it would not have been there, it was not thread safe, right? It would have created problem or any particular race condition and all or deadlock. So when you try to avoid this by writing that thing, those code are called thread safe, is as simple as that, or anything specific you are thinking.
Okay, thanks.
I mean, if it is anything there, let me know what topic or what you are thinking. Like
Amit,
writing thread safe
why
code
have
means,
you?
yeah. Tell me.
Sorry, no, the same thing. Just a follow-on question. Why have you said, from a design perspective, that loggers or logging API should be thread safe? Is it because we are going to log to some common database or like?
Yes, log to some common files. So all wherever from you are logging as a user, it will all logs should be go to the same file only, right? That's how logger works, right? All the logs are in the
Yeah.
same particular text file. So if there is a
Okay.
multi-threading in your code, and at one thread is trying to log, other thread is also trying to log, what can happen is same thing. It might happen that half of the log is there and then other threads half log is there, then other means it will be all jumbled up in your file.
I see. Okay.
Getting the point, right? What I'm saying.
Yeah.
Okay. So you have to make that logger thread safe. Correct. So I'm taking a clean file here so that I don't see if it is running and all. See out code started handle, and if I empty demos, cmake cmake dash build dot So main2 it is running and generating code and debug demo. Okay, everything is working. Now we'll look at std promise and std future. Okay, there are two things. Std promise, they work together. Now when we are going to use this promise and future, does anyone have any idea when to use promise and future? Anyone has used it?
Is it similar to async await in C sharp if you know C sharp by any chance?
Even async await is there. Means await is not there, but async await is there in this also, in C++ also.
Okay, so that this is not the same.
Not actually, async await is actually a wrapper above promise and futures.
Okay.
I'll tell you how. Right. So why, when are we going to think about promise and future? When are we going to use it? So whenever, suppose I have a function, suppose let's call it void, give me some value. I'm just giving some random name. And suppose I, okay, let me give it some meaningful name. Give square. Suppose this, whatever the number I pass, I have to return square of it. Right. And I take a number, int num, and I have to return the square. Because it is a void, I cannot return. So what are other ways that I can get a square of the number? If I create a thread, suppose t1, and my starting function is give square, and I have to give, suppose, square of 5. So how will I get the, suppose I take it here in this variable or whatever it is, like, okay. So suppose I'm passing 5. So it will come here as 5, and I want to say int square equal num into num, suppose. Now, how will I pass this value back to the main thread? Whoever has created this thread, how will I pass the return value? So there are two ways. So earlier we had seen this, right? We had also created programs like trying to take sum in parallel. We were also passing the values to back to the caller. We are getting the result back to the caller if you would have done it right. Remember? We had this scenario we even wanted to calculate something here and pass the result on the main thread.
By
So
reference was one way.
Reference was one way, right? So suppose I take var equal to 5. And then we are passing it as reference here, by reference, as var. Then whenever it calculates, I will have to do what? T1 dot join. And when it would have calculated, I could have print the value of var. Is it fine? Now we'd have got the value, and I would have to take like this. We'll get the value of var, so we'll get the square, right? Everything is we have discussed this, how to get the reference and all, how to pass. Okay. Okay, we'll not get into this, sorry. We'll have to put inside this num, then only we'll get it. So we can call num equal to square. Just putting it out. Now it is correct, right? So num will have his value changed, and it will come inside this var, and then you can print. Is this correct? Get the square of the number. Okay, but can you see how much we have to go through to get the answer? What if I want to do something like this? I am passing the value. So suppose 5, and if I want to get the result of it. So suppose I need to have something or some storage where this, once it is calculated, suppose in result, once it is calculated, my result should get inside that. And then whenever I want, I can get the result out of that. So suppose, let me make this clear. Suppose it is there. And what we can also do is, suppose I take a global variable, suppose int result. First, let it be 0. And what we can do is we can put it inside result. And whenever it gets calculated, I can like see out the result here. But what could be the problem with this? Any idea? With this also we can get the result here, right?
Right.
What could be the problem with this code? Correct. This is not thread safe code. What if I have one more thread that is trying to calculate the square of 6, suppose? Then how do we know which result I'll be getting? I have no idea whether I'll be getting the result of 5 or 6. Correct? Right or not?
Yeah.
Right. So comes the future and not options, future and promises. So we have to include future. I think it is inside future. You have to include future to use promise and future. And then what we'll do is just check this properly. So I don't need this now. You just have to know this code once, and then it is very simple how to use futures and promises. So what we'll do is we'll create a promise of type what? Our result will be in int, right? So promise of type int, and let's call it something PR. And then also we have to have future of type same type, and let's call it result. And what we'll do is PR dot get future. These two lines you have to write. Okay. And what we'll do now is we'll take a promise here. So let's call it promise of type int. Let's call it PR. And then whenever the result we have got, what we'll do is PR dot set value. And then we'll push the result inside this. See, this could be where end result. There could be a lot of code that could have been written, and we never know how much time it takes to calculate this value, right? But whenever the value is calculated, we are setting the value inside this promise, what we have passed from, what we'll pass it from here. So we can pass this value from this PR from here. Similarly, PR from here. Right? Now, so we are passing this promise, okay? Right now we are passing the same promise to both the threads, right? So it will give the same problem will be there. So what we can do is we can have two PRs, PR1 and PR2. So for this result, I want in PR1, and for this result, I want in PR2. Okay. And then there's two futures. Suppose future 1 and future 2. PR1 and PR2. Okay. So now, suppose for this particular thread, which is trying to calculate give square, right? If I want, I don't need this now. If I want, suppose I have a lot of code written here in the main thread, I'm writing a lot of code, right? But after some particular point of time, now I want the result of this, whatever the give square I've given. I want the result of this. What is the result now? So at that any particular point of time, we want the result. What we'll do, we'll get it from the future. So res1 dot get. That's it. It will give me the result, and it is what? It is type of int, right? And then that you can print. If you want other result, want to do, you can say res2 dot get. That's it. And what this get will do, this promise, this future get, what does it do? The moment it tries to see get, it will block. It is a blocking call, this get. If the result is already there, if this code has already been executed, it will quickly give you the result back. You will get the result back directly here, and then you can use it. But suppose when you have done this res1 dot get, and still this value is not calculated, basically this code has not been executed yet. So this your thread will get blocked there, and it will wait until the result is there. Until result is there. This is the whole concept of promise and future. That's it. You set the value in promise and you get the value from their feature. How you do it? Dot get. And how do you put the value? Promise dot set value. And that's how you can set the value in one particular thread and get the value in another thread of that result of that particular thread. That's it. That is the whole concept of promises and futures. And when do you want to use promise and futures? When you want to, in particular function, it will try to do a lot of logic and then it will produce some result. And then in other thread, you want to get that result, right? Without that result, you don't want to move ahead. And that point of time, you will do a get. And it is, remember this is a blocking call. If result is there, it will come back and it will give you the result. If result is not there, it will keep on blocking, right? And it would have made inside it would have created those threads and all. I mean, those mutex and all would have been there internal implementation. But if you don't want to go ahead with those all things, doing it yourself, you can just simply use promises and futures, right? This is just the theory. If you want, so in promises and futures also, you can set the exceptions also in promises and futures. So like suppose if you get some exception, so you can do it like this also. See, can you see set exception also that you can set? So if when you are doing future dot get, you'll get that exception also that you can handle. So you can put that future dot get inside try catch block and then try to handle it. Is this clear? Do I need to write a code for this? Yeah. Somebody was asking anything.
Yeah, will there be any situation where the thread function will return a value because it's only returning void? So there will never be a situation where it can return an int or something.
In this CPP library that they have given, a standard library, this even if you give an int that we have discussed, right, it will be ignored only, even if you return anything.
Okay.
So there is return or no return, there is no point, like it will be ignored. Right?
Amit, is there any way to check whether it was set or not the value? The promise is set or not before getting it?
Promises set or not? I think there is. Let me check. So res one dot. There is one thing called wait. So see, this is wanted to tell. So this, remember this raise one dot get is a blocking call until you get the result. It will keep on blocking this particular thread. So but if you again the same thing, try log for whatever we are doing now, you can do it here also. So raise dot wait. Sorry, raise one dot wait, and you can then do a wait for until what time you are keep on waiting for this result. And once, so you can put it inside if, and let's say you call it wait for some time. Let's say you can give within the chrono, let's say seconds, I think, like this. Let's say I'm going to wait for 1 second. And then if I'm not able to get it, the result till that time, what I will do is, once in some noises, I can do some other thing here because this is the main thread I can do, and I can put this whole thing inside while loop if I want that result. So this is my logic. What I'm saying is this is the business logic that you can write. So what I can do is I can do something, then I can come back, and whenever I have got it, okay, I have got the result, then I can do the this res one dot get at that particular point of time. I cannot do here. Res one dot. It doesn't matter about bool type or convertible to bool. I have left
Extra
one
bracket is
yeah,
missing.
extra bracket is missing. Fine, right? This is there, this is there. I hope this is a bracket only, but after this res dot get that you can do to get the result. Right? And also remember this one thing, once you have done res dot get on particular future, if you do it once again, this is undefined behavior, you never know what will happen. So you can only do a get only once for one particular future. You cannot do it multiple times. So also remember this is important. You can only do get once. Okay. Can we move ahead and quickly do a async? Just the theory, like it is simple only. Can we quickly finish this async also? I don't think there should be a lot of problem with this promise and future. Only thing you have to remember, create a promise, and whatever the promise, you set the value that you want to give in the result, and you take and in here you take the future out of the same promise in which you will be setting the result, and whenever you want to get the result, just do a result dot get, means basically future dot get. That's it. And remember, this is a blocking call.
Is it possible to notify after setting it from the promise side?
No.
Not
For
right.
notifying and all, think of condition variables then.
Okay.
Right. Can I quickly move on to async, finish this off today? And if
Yeah.
there is any confusion, we can take this tomorrow. Right? Because I wanted to start some of networking from tomorrow itself. Right.
Yeah,
So okay.
let's.
So I'm quickly starting with the async. So async is just made for to make our life easier. So instead of creating a lot of threads ourselves and all, this particular wrapper will create the threads and all for us. So suppose we have some function, let's say print value or something. Suppose we are printing something. So see out, let's say print and indel. Right. So how we'd have done it? We have created a thread like this, thread T1, and then given this. Instead of doing this, what we can do is we can simply say async and then give this particular this print value. This is one argument that it takes. And what does it return? If you see the return type, it returns the future. Right. So suppose this particular function, suppose instead of just printing, it might be returning, let's say, suppose it is returning 23, some value. So instead what we'll do is, so it has to be int return type because it is returning value. And what we'll do is, because now I have given that it is a return type, I can, and if you see, if it is a future of int, like whatever it will return type, no, future of that type. So it will return me future of int and then suppose result, and the same, whatever we studied in the future. How do we get the result? Result dot get. That's it. So we name, so what this will async is doing is, and to include async, I think is in future only. We no need to include anything else, future only. So what it is doing is async. The moment you ask async and you are giving this starting function where to start, it will automatically creates a new thread for you and give this as the starting value. So suppose now you have to pass some parameters also. Suppose some parameters also you have to pass. Where can you pass? You just pass it afterwards. The same as you are doing in thread creation. Right? I mean, this should be simpler. That's why I'm going fast. So what you just have to understand what is happening. Whenever you are saying async, and you give a starting function and whatever the parameters it needs this function, you give it afterwards. And what does it returns? It returns the future of the return type of this function. Right. So instead of using the future and promises directly, you can directly use this async. So earlier example also, while calculating the square, we can directly use async, and inside directly we will be using this future of int and res. Internal implementation would have been same as it would have been passing promise and it would have been returning the result. The promise, it would have been taken care by itself. This async would have been returning the promise of that particular future. Right.
If there is a multiple async, and what about the order of it?
Order of? So suppose you have 1, 2, 3 more. Suppose like this. Yeah, the order of same. Don't think of the order. Internally, whenever you see async, you think it would have been creating a thread, same as what we were creating. So do you recognize the order when we create? Right? It could be in any order, right? So same. Async is nothing but a wrapper above futures, promises, and threads. If I have to say it in simple words. So instead of me creating threads and futures and promises and everything, I just do a async. And then this is the signature. You get the result, and whenever you want the result, you do a result dot date. Again, this is a blocking function. So our life is made simpler with this. Now, there are few things that you need to know about async. The first thing is it also takes, if you don't give anything, I'll tell you first what it is. So there are two types of launch policies that it takes. I think it takes, the first parameter is launch policy, no? Okay, let's see. Launch Okay. So if you see like this, if I give a launch, there are two types of policies. One is async and one is deferred, right? So there are two ways that you can start the thread. So if I give async, the first parameter is async. What it will do is, it will at that particular point of time when the code is executed, it will create a thread. And the same thing, how it happens, it will create a thread, and this print value is the starting function, this parameter is getting passed, and it returns the future. But what if we give deferred? What will happen in this case? Instead of creating a thread at this particular point of time, it doesn't create a thread. In fact, it doesn't do anything. It whatever it has to set up and all, it will do, but it doesn't create a thread. If I do a async of launch deferred, means what I'm saying is, please don't create a thread right now. I just have set up everything, but don't launch that function right now in a separate thread. What it will do is, whenever I'm doing a result.get, at that point of time, it will call this function, and it will be a sync function, not even in a separate thread only. So whenever you are doing a get, it will go to this function, it will create the value, and it will give you the result. Then you will ask me, why do we need even that deferred, right? We can simply call this function print value. Isn't this the question? Instead of doing launch deferred and then result.get and get the value, just simply call the function, because internally also it will do the same thing. Whenever you do a get, it will that time it will call the function and will give you the result instead of creating a separate thread.
So for
Are you getting the
flexibility,
point? Yeah, for the flexibility. So suppose in your algorithm, you will decide, I'll set these things up. So suppose I can do it like this. So suppose there is some business logic you have. Hey, if my CPU memory is this much, or if my already thread has been created this much, let's make my let's int option is equal to, let's say, 1, right? And here what I can do is, I can change it like this. So launch equal 1. Oh, sorry. So launch equal 1. Then I can do it like this. So launch async, or else launch deferred. I can have some business logic, like where option 1 can be somewhere. Okay, if my resources are already used much, I can set my option as, if my resources, if for this particular point of code, if my resources, we have many resources, I can set my option as 1. If I don't have resources, I can set my option as 0. So if it is 0, I will launch it as default. It meaning saying that, make it a sync function. I don't want to launch it on another thread. But if I have resources, you can launch it async, right? So if I do a result.get, if it is being deferred, then it will calculate the value at that time. If it is async, it would have created a thread and it will give you the result, means parallel execution. This is the whole theory about async, nothing else. That's it. That's what I'm saying. If you have understood that much of multi-threading, these things are just making our life easier only. No complexities here. So next time, yeah, tell me.
If you have a shared variable, so these mutex and all these things applies to async as well, right?
That, see, think whenever I am doing async, think that internally it has created thread only.
Thread only, okay.
Yeah, it's nothing special. That's why I'm saying, telling it is just a wrapper above that. Thread, promises, and futures. Async is a wrapper above threads, promises, and futures. Getting my point? So next time, if you have to create something in a separate thread, you can directly say async starting function and all the parameters that you have to pass, and it will give you the result. So in fact, you can even forget about using promises and all, because internally this is doing promises only, promises and futures. So when are you going to use async? Whenever you want to do some calculation in parallel and get the result back, you can do it like this, async, and you get the result here, and then do a result.get. And don't forget, this is blocked. I'm telling it multiple times. Don't forget this. Whenever you do a get call, it is a blocking call. Right? So this is the whole thing about async, promises and futures. So give a lot of time to whatever we have done earlier. Creating thread, understanding producer, consumer, condition, variables, all different kinds of mutexes. If you have done this properly, then you just know this syntax. That's it. From next time, you have to create a thread, just put async, and that's it. Then, right? So I'm wrapping this for today now. So it's already 4:15. So now if you have some question, you can ask. The first thing we'll start tomorrow will be a lock-free programming, and I'll try to start the networking and socket programming from tomorrow only. Maybe in the last 1 hour or 45 minutes, we'll start.
Amit, like one question is like, so in generally whenever we debugging the multi-threading programming, right? So we feel difficulty like so why?
Yes,
Because
yes.
the thread rates will be changing the like for every breakpoint, right? So can we know like many debugging tips? It would be like helpful. Yeah,
I'll
when
tell. I'll
so
tell.
if you have,
When we'll be doing the socket, no, we'll be doing it in multi-threading, and we'll see what kind of error can come in the socket programming using multi-threading, and we'll try to debug at that time also. And I'll tell you a little what all this code, how to read code dumps and all. I'll tell you at that
okay,
time. That those are very
okay,
helpful.
okay,
In
sure, yeah,
production also, no, you mostly will not be able to do the debugging, right, on production machines. So at those point of time, those code dump, reading code dump and all is very helpful. That I will tell for sure, because I think that is very important. Understanding and reading code dump files, right?
yeah, sure, thank you, yeah.
Yeah. So yeah, any question or anything?
Yeah, Amit, I have one small question.
Mm,
I understood
mm,
the thing that you mentioned as a wrapper for everything, right?
mm, mm.
I can assume that whatever the print value function contains, right, that critical section is also handled as part of async, right, internally. Even if there is any critical section present in the print value.
No, 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 no. Not like that.
That will
That you
be
have to
that
take
will
care.
be
Yes, yes, yes.
okay.
If you launch a thread, suppose you launch a thread and you don't give a mutex, does it handle automatically? Right? No, right?
No, 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 no. I think it's
So
simply a
just
thread,
think,
right?
yeah, it's a simply inside async, it's creation of thread and then passing all the values. And then inside it might have been passing promise, and then you are getting the result in future. That's it. No mutexes and all. That you have to take care.
Got it. Got it, Amit. Thank you.
Yeah. Is promise and async also comes under lock-free programming? No. There means there means it's not like it is not a lock-free programming. Lock-free programming only means we'll not be using lock to synchronize things. That's it. We'll use something else, which is atomics. So there is programming paradigm also called wait free, and then there is lock free. So wait free is will not do. Mostly people not do only wait free, but it's just the most of a theoretical concept, and it's very hard to implement. So we'll use lock free. Okay. So if we do not have any question, can we wrap up? And please, can we make Discord more active? Only I can only see one person who is very active. Otherwise, no one is active on Discord. I don't think anyone is doing anything. So, I mean, anything means no one is writing code or anything. At least what I understand from the Discord. So please write, because now we'll be starting with the socket, no? We'll be writing, means we'll be doing some interesting stuff. So I think it should be interesting. Not means I don't do anything for the interviews or anything. Do it for the sake of development and being a code developer and all.
We are
Right?
trying.
Means whatever you try and put it on Discord. That's it. At least I'll get to know, okay, oh, people are interested in it. At least what I've been trying to put across is people are getting it and people are actually getting interested in what we are studying, right?
No, as far as
Mm,
interest is concerned, it is
mm,
very enlightening because I realized that I was thinking I'm good in C++, but after this, I felt that good that I came across this course. Otherwise, I would have gone unprepared and somebody will ask these questions and you will falter.
mm. These things are so for the interview point of view, just remember those things: producer, consumer, reader, writer, deadlock. Also, one more thing is there, which is called live lock. People may ask what is difference between deadlock and live lock. Does anyone
Oh,
know what is live lock?
I don't know.
So you understand what is deadlock, right? So two threads trying to compete with each other, and no thread is trying be able to go ahead with the code. So one is blocking one mutex, another is blocking other mutex. We understand deadlock, right?
Yeah,
So
yeah.
if we understand deadlock, what happens in live lock is two threads with two mutexes, suppose two mutexes, both will be able to move in the code, but will be always in the loop only. I am trying to take a mutex. I will not be able to. I'll go back and come back again, trying to take a mutex. This other thread will be again logged. It will try to take other mutex, again log. But meaning both threads will be moving, but no one is actually moving in the code. Both are moving in the same loop. So that is live lock. Means deadlock means all the threads are just at the same point. No, not moving only. But in live log, threads will be moving, but not actually moving in the code. Means moving
No,
in the
didn't
code, but not doing anything particularly.
we didn't get actually.
Read it once. Let's discuss.
Okay.
So, but there people can ask what is live lock and what is deadlock. What is the difference? So there is a subtle difference between two. So good for the interview question.
Amit, one more question I have. Like, I always get confused between how bind is used and how parameter pack is used. Like, you have used that in
Okay. Okay.
Deadpool, right? So,
Okay, we'll take it.
okay. Yeah.
Okay, one I wanted to take was the recursive mutex, right? Can we can some who was asking, can we take it on Discord when you write the
Yeah,
code
yeah.
and check what was happening? Pooja,
Sure,
right?
sure. Yeah.
Can you also write it and check what is
Yeah,
happening
I'll
in
write it and
recursive
share.
mutex
Yeah.
and share, right? Okay, thank you.
Yeah.
Okay. So shall we wrap it up? We'll start from tomorrow, log-free programming, and hopefully we'll start with the socket.
Sure. Okay.
Next,
Thank you.
Yeah, sure. Thanks.
next weekend, no, one thing, next weekend will be very interesting. Promise.
It
So
always was.
Yeah.
till this week, everything what we were learning was like basic stuff. Now from next week, we'll be learning some advanced stuff also, and also interesting in the sense that we'll be data will be moving from here to here, and we'll be looking some advanced stuff also, and it will be interesting. So at least have these basics clear till that time. Till next week, we'll be starting with, and good project also will write. Right. So right now I'm just showing some simple random code and all, but from fourth week we'll be writing proper code.
Okay.
Okay. Okay. Okay. Then let's wrap it up and goodbye. Thank you, everyone.
Thank you.
Okay.
Bye.
Bye bye.
Okay. Okay. Thanks.
Bye. Thank you. Bye.
Yeah.